Welcome to this episode of the Clay Minerals Group interview series. My name is Alastair Marsh, and I'm the secretary of the Clay Minerals Group. The CMG was founded in 1947 as one of the first special interest groups of the Mineralogical Society that have contributed so much of its life and success. In 2022, the CMG celebrated its Jubilee anniversary of 75 years and started a series of online interviews highlighting the diversity of minds and hearts behind the fantastic world of clay mineral research and applications. Today, it is my great pleasure to introduce not one, but two clay scientists, Deeba Ansari and John Phipps. Dr. Deeba Ansari is the Science and Technology Director of the Paints and Coatings Division in Imerys. She first joined Imerys in 1988 and ever since has worked in various positions in research, product, and business development. She grew up in Cornwall and still works in Cornwall, and in between has also worked in the USA. Her PhD thesis at the Department of Chemistry at the University of Bath was on the study of polymers, minerals, and their interactions by inverse gas chromatography, and she is a Fellow of the Royal Society of Chemistry. Dr. John Phipps is the Senior Manager for Development of New Polymer Products at Imerys. He first joined Imerys in 1992. He works there now and has interspersed his time with stints at other organizations, including Schlumberger and Fiberline Technologies. His PhD thesis at the Department of Chemistry at the University of Bristol was on a neutron reflection study of adsorption at liquid interfaces, and he is also a Fellow of the Royal Society of Chemistry. So it's great to have you both here this morning. To start with, I'm going to give you some free advertising. So, Deeva, for you, for people who have never heard of Imerys before, what does Imerys do?
Well, thank you. And thanks for inviting us here today. It's a pleasure to be here. So Imerys, we're the leading industrial minerals producer in the world. So we are about a 4 billion euro value company, traded in France with about 15,000 employees around the world. So our core business is in the extraction and refining of minerals, and those minerals are really non-metals. So they will include the clay minerals like kaolinite, chamots, illites, bentonites. It also includes talcs, calcium carbonate, mica, diatomite, perlite, andalusite, graphite, and carbon. So those are natural minerals. We also produce a large range of synthetic materials, mainly for things like refractories and abrasives. So calcium aluminates for cements, for example, and a whole range of other things. So really, we're a very broad company. We cover a whole range of markets, which will include construction, batteries, plastics, rubber, paints that John and I are both focused on now, paper and board, and many other things. So, as I say, a very broad brush company covering most applications you see all around you.
Great. So a big company with a very broad range. Let's go into a little bit more detail in your own working lives. So, John, for yourself, what are your current specific interests around research and development of clay-based products?
So I'm currently in the polymers group in Imerys, although I've been in most of the groups throughout my career, and we focus on adding minerals to polymers or plastics, if you like. The main areas are in the biggest ones are in automotive, for example, where you'll see a lot of talc in external parts made of polypropylene and other polymers, where the talc is used as a reinforcing agent. It allows you essentially to increase the stiffness of a relatively flexible polymer and make it suitable for those applications. We also have a large business in film products, which is actually not clay, it's calcium carbonate, where the calcium carbonate is added to the polymer, typically polyethylene, at very high amounts, up to around 50%. That's then blown into a film and then stretched, and around every calcium carbonate particle you get a tiny little defect, a hole, and you're going to end up with a breathable film which finds itself in all sorts of applications. The one we usually quote is on the outside of babies' diapers, which makes them breathable but waterproof. So it's a fairly low cost way of making that kind of film. So my interests are in developing further applications, improving the products, etc. One of the focuses at the moment is on the role of the minerals can play in flame retardancy in plastics, because there's a big demand for that, particularly in new markets such as electric vehicles, where there's a lot of plastic material to try and keep the weight down, but it has to be flame retardant.
I'm always fascinated more and more about the range of different products one can use clays and clay minerals in. My instinctive mental association with talc is as a child going to swimming classes and just the change rooms being covered in white powder from people drying themselves, which is thankfully banned now. But I'm glad it's being used for some more high value applications. So Deeba, how about yourself? What's your kind of product focus at the moment?
Yeah. Well, if I concentrate on a couple of the areas that we're working in, so clays are used very widely in paints. So things like decorative paints can contain a high amount of both relatively fine clays. They bring within decorative coatings, they will bring opacity to that material. So when you paint it on the wall, it covers the wall well. It brings a certain viscosity and also weight to the paint so that it flows well, but it also sort of settles on the wall to give a very even finish. So we're still doing a lot of development work in that area. Also, calcine clays are used in paints as well, again, to bring a higher level of opacity, but also a very high whiteness, because obviously colour and consistent colour is really important. I also support the board and packaging industry, so the non-graphite papers, for example, and packaging. So special blends of clays and calcium carbonates are used for coating certain types of paper, again, to give the right printing properties and the right colour and smoothness, so you get a very smooth surface on which to print. So some of the glossy magazines will still contain a fine layer of calcium carbonate and clay blends, for example. That we're also doing more and more work around the use of clays as barrier materials, particularly in, for example, certain packaging, where it can bring a barrier effect. So rather than using, say, a plastic, we're removing the plastic and trying to have a barrier effect with a mineral. So a lot of our projects are driven, and it's part of Imerys's philosophy, 75% of our projects need to be driven with a positive sustainability goal in mind. So, for example, the removal of plastics to allow packaging to be recycled is one sort of goal. Having coatings, for example, on the outside of buildings that may be able to last longer, so you use less of that material over time, therefore reduce wastage and so on. So it's good to see that the drivers for change meet with our sustainability goals and our interests in developing new products, which is what we're doing.
Okay. Fantastic. So, you mentioned paints there, and I'm aware that, humans have used a variety of clay-based products for thousands of years. So obviously, what we're talking about there, in certain areas, we're kind of always looking to build on and improve that knowledge. But looking more to the future, in your opinion, which clay-based products or technologies do you think have the most unfulfilled potential in the future, especially for those sustainability aspects you mentioned? Deeba, for you first, please.
Okay, well, it always amazes me, and I think you said the same, that we're always finding new uses for these things. I think the advantage we have is because of those drivers that we have been given by the company to really focus on. So things like, for example, geopolymers. Geopolymers using metakaolin sourcing. We've developed some of those that can be used, for example, to improve insulation. So instead of having an insulation based on perhaps a polyurethane foam, you might want to replace it with a geopolymer, which is, a clay-based solution, which is a natural material. And what we're certainly seeing is a revival of the replacement of synthetic materials with more natural materials, and clays are clearly part of that. So that's one example. I don't know, John, if you've got anything that comes to mind for you.
Yeah, I mean it's quite difficult when you work in an area like we do, where most of the applications are well established, they're mature markets. I mean, you have to those remain important, and so even though they might sound a little bit dull and not futuristic, I mean they're the focus of what we do. But there are some interesting new ones, usually in areas that I don't know much about. One that caught my eye recently is the use of clays as solid electrolytes in fuels and fuel cells and batteries. And a lot of that is involved in doing things like intercalating bentonites with different materials. And I think there's a huge potential of what you can do with intercalating clays with different types of molecules. I mean, traditionally, it's always been the organoclays, where you essentially put a layer of alkane, usually with an ammonium group on the end of it, in order to make them hydrophobic and make them disperse in oil-based drilling fluids, for example. But there's a whole host of other things that you can do with expanding clays, and I think there's probably lots of potential in those for new applications.
That's fascinating. I presume the interest in electron materials is driven by the high specific surface area and be able to engineer with that with intercalation, I suppose.
Yeah, I guess so. Like I said, it's not an area I know a lot about, and often you find the areas that you don't work in are the more exciting ones. But yeah, certainly. I mean, we do have we have our graphite and carbon division that does a lot of work with batteries and fuel cells, of course, focusing on the graphite and carbon side. But also we have an advanced ceramics division, which is not based in Cornwall. They're based in Austria, and they study a lot of these kind of materials.
Yeah, and just to go back to, sort of ceramics, for example, which is a traditional industry. And I think we shouldn't forget that we have a thriving industry currently, of clay materials from around the world. We're based in Cornwall, where we still produce, 600, 700,000 tons of clay annually from the central Cornwall location, used in paints, coatings, paper, board, ceramics. But, ceramics is moving on as well, and we're very strongly focused in that area. So, for example, being able to lightweight, for example, tiles. If you think about just bathroom tiles, they've gone from little squares to being quite large pieces to now being very large slabs that are lightweight enough for people to be able to still pick them up and put them on the wall. And that lightweighting is due to the technologies that we've developed within the clay mineral space. So, even though it's still a ceramic tile, the ceramic tile of today is very different from where it was 10 years ago.
That's fascinating. I had no idea because I mean, we're talking about a home, about bathroom renovation at the moment, and I kind of noticed, but I never really thought of like the material innovations that kind of enabled that scaling up of the tile size. Amazing.
Yeah.
So let's move on now to back to yourselves personally and your journeys through your career as clay scientists. So, John, having a look at your background on LinkedIn, I see that you started off your career in PhD research in some quite fundamental topics about neutron reflection. So, what was it that then, after this, drew you into industrial research and development?
I guess I see my whole career as a series of decisional branching points, and unlike, I guess, some people, there's never an overall plan really. So at the point when I finished that, I had been working in a group that was doing a lot of fundamental colloid science, which is applicable very much to the sort of things that Imerys does. right back at that time, academia wasn't very attractive. There were loads of people postdocing after doing postdoc after postdoc, searching for positions. So industry seemed more attractive. And I found this job at a little company called English China Clays down in Cornwall, which was a very attractive place for me to go because I'm a very keen windsurfer. So essentially, it all came together with that, and that's where I started. So I spent about 8 years there, and then along came Imerys. The company became Imerys in about 99, 2000. And it was a big kind of shake-up, and Imerys was very much a company that grew by acquisition of other companies. And at the time, they didn't really have much of a focus on research and development. So I saw that as an opportunity to go and do something else. And largely through the contacts that I had, I ended up in Schlumberger in Cambridge, working on oil field drilling fluids and oil field cements, again with the sort of particles colloid science connection. And I worked there for sort of 5 or 6 years. And then I moved to a little technology consultancy just outside Cambridge that did a bit of everything really. We did a lot of short jobs. I studied things like the market for catalysts, things about shampoos. I did a project which I really enjoyed for Carlsberg on trying to develop a draft beer keg that you could keep in your fridge that was driven by carbon dioxide absorbed onto carbon activated carbon. But during that time, I did a couple of jobs for Imerys, and one of my old colleagues said, "Well, it's a bit different now. We do lots of R&D now." So he tempted me to come back to the sun and the surf and Cornwall, and so I ended up back here. And then I was involved in a project using our grinding technology to make microfibrillated cellulose, and that kind of became Fiberline Technologies, and that company was sold. So despite the fact I didn't even move desk, I moved company completely. But eventually I thought, well, I'll go back to Imerys, and then I found a job in the polymers group. So I've moved around quite a lot, and like I say, it's really a series of decision points, really, rather than a grand plan.
I see. I'm always amazed that so from the same core set of skills, you can apply this in so many different
Mhm.
areas. I think that's a wonderfully eclectic range of examples
Mm.
there. So for yourself, Deepa, I think there's a few similarities with John's career path, but also some key differences as well. One of which is that I see that you worked in research and development in the clay industry, and then did your PhD research whilst embedded in industry. So I'm curious, what drew you to that route? What was it at that time in your career was like, you know what, I'd like to do a PhD on this now?
Yeah, well, I mean, I've always been keen to study, and I have with Imerys mainly throughout of my career, and I'm very thankful to Imerys for giving me that opportunity. And I just wanted to continue to do some more fundamental research. But at the same time, I was working, so I found that I was really interested in surface science at that time. So we were running a project to look at the interactions of minerals and polymers. So I was working in polymer research at the time, and really understanding fundamentally why or how you could get the most perfect alignment between the surface chemistry of one material and another. So I wanted to do research. I went to Imerys. I found Dr. Gareth Price at the University of Bath, who was working on inverse gas chromatography, looking at the near surface of materials, or the pure surfaces of materials. So that allowed me to continue the research I was doing about minerals and polymer interactions, mainly calcium carbonates, I have to say, and I'll talk a little bit about the film link developments that John's spoken about, but also things like silane treated clays and their interactions with certain polymers, whether it's rubbers or polyamides, for example, with aminosilane treated surfaces. So being able to understand how you optimize one material to combine it with another. So the research that I wanted to do, which I found really interesting, also fitted with the research that I was doing at work. So by day, I was sort of doing my day-to-day work, and in the evenings, weekends, I was working on the same sort of stuff, but towards my PhD.
See, that sounds like a wonderful harmony you managed to get there. So, you both mentioned that you've worked on several different product application areas in your careers. So, staying with you, Deeba, what would you say in reflection are the benefits and challenges of moving between those different products and sectors between year to year?
The benefits, I mean, I think as a scientist, you have a lot of curiosity. I certainly do. I love new challenges, and in order to continue to have challenges, you need to be able to move. You need to be able to look in different parts of research, or and I think the other benefit is, and certainly that I've done, I've not just worked in research. I've worked, as you said, in business development, in product development, very much embedded in the operations in some instances. So understanding that helps you inform you about the research that you do, what you can and can't do. Knowing about the business, we're very much, research is business and customer focused. So knowing the areas in which we work in the business and where we want to develop certainly helps with those challenges. You said about, so those are really the benefits of being able to have a very broad view of how the business runs and keep you interested and informed. And I come to work, and I have done every day, with something new to think about, and that keeps my brain active and keeps me really enthusiastic about what I do. I think the challenges in a large organization is that research sometimes needs to think a long time ahead, and business is more focused on the day-to-day. So one thing that's critical for good research is you have to have a research organization that is somewhat independent in some ways of the business, but absolutely driven by the needs of the business. And those two things can perhaps have a different speed. So we are thinking about 3 to 5 years hence, 3 to 5 to 10 years, I would say, hence. And the business is looking at what is happening, each year, annually, according to budgets. But so we have to, be focused those and align those two slightly different timelines.
Got it. So achieving that kind of a positive tension between the two.
Yeah.
Excellent. So, John, would from your experience, the benefits and challenges, would you say those similar, different to those that Deepa mentioned just now for herself?
Well, I think it's similar in many ways. I mean, and as you can see from what I've explained, I've moved around sectors quite a bit and companies. And the challenge is always, the interest for me has always been learning new stuff, learning new things. But the challenge is that by the time I become a reasonably expert in something, I move on to something else. So I never have that comfort of feeling, oh, I'm a world expert in such and such, because I'm not anymore. I moved on to something different. And I'm one of the people who doesn't really like to say things that I'm not 100% confident are correct. So that can sometimes be a little bit challenging, but certainly the interest in moving between applications and seeing the common links between them, and how, if you develop a way of thinking fundamentally about how things work scientifically, you can actually apply that to new areas and pick them up and understand them reasonably quickly without having to have absorbed a massive empirical knowledge. I mean, I see that. I don't know whether they say fortunate or not, but despite not being an academic, I get quite a few papers I get sent for peer review, and quite often I look at them and think, ooh, I don't know anything about that. Oh, I'll give it a go. And actually, I find that even if it's in a field that is really quite tangential to mine, it doesn't take too long to understand it and to be able to critique it reasonably, because of that basic understanding, that approach to understanding fundamentally how things work and how science is done.
I'd say that's actually, my personal opinion, really encouraging to hear from you both, because especially in the early career, there can sometimes be a sense, maybe especially at some of the tougher events or conferences that you really should sort of stay in your lane, just like, oh, but you don't do this, or like, oh no, it'll take you too long to move into this. But actually, I think what you said, if you do have the a solid fundamental basis, yes, it takes some time, but you can move in these areas, and there are advantages from doing so. So that's quite a hopeful message, I think. So a couple of more questions about career experiences, maybe a little bit tougher. So again, with yourself, John, what would you say is the proudest moment or the greatest satisfaction of your career so far?
I think that's quite a tricky one. I mean, people will often quote to you that, if you work in R&D, industrial R&D, you've got, I don't know, 1 in 10 chance of your project succeeding, for example. And I've always been driven by the possibility that what I do in my work has a big influence on the business, that ultimately people end up using it. And so a lot of those projects have been technically quite challenging, but they and have succeeded technically, but have ended up not being a commercial success. And then actually, when I think about the thing was the biggest commercial success of all, it was probably a couple of months' work, if that. But it influenced essentially what we made for magazine paper. We looked at the particle size distribution, the steepness, and we sort of determined what it was we needed to do. And I mean, that saved a huge amount of business and ended up being hundreds of thousands of tons of clay from Cornwall. Whereas there have been other more challenging projects I've done, like, for example, at Schlumberger, we wanted to replace cement with a more effective polymeric kind of sealant. So I had to sort of devise a completely new way of doing something which you could pump down a well 2 miles deep and have cure at the right temperature at the right time. And we solved that one, but in the end, the sort of demand was not high enough. The cost wasn't quite right, so it didn't quite make it.
See, that's a fascinating example of what should we say, the non-linearity curve of technical input effort and
Yeah.
commercial payback. But really nice example. Thanks for sharing. What about yourself, Deeba?
Well, I think there's two aspects to your question, really. One is about developing products. So I'd say in terms of that, my proudest and probably the most, from a business perspective, the most valuable is that I was half of the team that developed the film link products that John was talking about. So I led the research group in the UK for Europe to devise a calcium carbonate that was going to permit this breathability in film. And my counterpart was Alison Calhoun, who was based in Georgia, and she was developing at the same time a product for a plant in America, and we were looking to build a plant in Europe. So I ran the research group in Europe to develop those products. And actually, part of my research, the PhD work, was looking at perfecting that surface coating of that material to allow to get the porosity just right with low defects. And I worked on actually developing the footprint of the plant, so how we built the plant itself. And then I was fortunate enough to go to Lix in Belgium, where we built the plant. So I was there in the build phase, in actually bringing in the engineers to actually run the plant, in developing some new tests in order to be able to have the right quality control for it, and then in launching the product. So we had a nerve-wracking product launch, which actually in the end went well, very well, both in Europe and the US. And Alison and I are the co-inventors on the patent for Film Link. So that was, and we still sell the products very widely today, not just in America and in Europe, but also we have plants in Asia as well. So I think.
Sorry, just to understand because you mentioned so many different things. The film links, is that related to the nappies?
That's right. This gives the porosity to breathable films, whether it's nappies or roofing membranes, or medical cloths, disposable medical cloths that are used in surgical theatres. So yeah, so that's one aspect. The other aspect, which I think is really important, is as a people leader, as a people manager, is developing the people, developing scientists to think in the way that we've been, John and I have been allowed to think in a free way, in an inventive way, in developing those people and giving them the skills or assisting them with new training or whatever. And I've been really fortunate in having people who've come from apprenticeships, from school leavers, from doing their certain qualifications with us, or bringing in PhDs, bringing in a whole host of brilliant and amazing people that in some way I've been able to touch their careers and help them along their path. So that, to me, actually, of all the things I've ever done and do, that is the most fulfilling for sure.
Well, so I really like this thinking of this in the two categories. And just out of curiosity, so you mentioned, the people management and the people leadership aspects. For yourself, did that always come naturally to you, or did that sort of take some time, some years to develop your own personal style around how you did that?
Yeah, well, for me, I've always had a natural tendency to take, lead things. It's just inherent in me. I think it comes from my mother, who's has very similar traits to her. But again, and I have to thank Imerys, that they have a leadership program. They identify leaders of the future. I went on a senior leadership program, and that helped me be the type of leader that I am, and train me to use what I have naturally, and also where my shortfalls are, to understand those, and to be able to develop my leadership skills. So yeah, it's been a combination of leaning into what you do naturally as a leader, and then being given the skills and training necessary by the company.
Okay, that's fascinating. So getting towards the end of our time now, so we'll finish with a couple of, let's say, more fun but still clay related questions, sort of. So John, you mentioned the windsurfing being a factor, taking you back to Cornwall. Is that something that you still do regularly now? And in general, when you're not working on clay products, what do you like to do?
Well, sadly, I don't windsurf quite as much as I used to. But it's the whole has kind of been filled with cycling, actually. I mean, right from the very start of my career, I always wanted to ride the bike to work rather than drive. And I've done that everywhere, or I've managed to do that everywhere I've ever worked. At the moment, it's a 13.5 mile trip from my house to where I work at Palmore Centre over in Imerys. And that's led to me now joining a cycling club. So I do silly amounts of mileage most of the time. But yeah, for me, there's always been an active sport like that. At the university, it was rock climbing, then it became windsurfing, and now it's cycling. And that really, I think, keeps me healthy and keeps me grounded.
Okay, great. And for yourself, Deeba?
Yeah, well, yeah, we're very fortunate that we have one of our technical centres based in Cornwall, and that I've been able to on and off be here for my most of my career. So yeah, I love the outdoors as well. So hiking, cycling, swimming, going to the gym, all of those things. But yes, just being outside in nature. I'm very keen on nature, natural history. So going out and being able to bird watch and see all the changes in the seasons, or looking at the butterflies, looking at all the amazing plant species, etc. we have here. So yeah, being out in nature in Cornwall is a great thing to do, and I love it.
Yeah, I mean, in that part of the country, it would be rude not to, in a way, wouldn't it?
Yeah, absolutely. Yeah.
And last question, I think it's maybe a predictable, but John, what is your favorite clay mineral and why?
Oh, I love them all.
No.
I haven't had the chance to work on them. One of my current focus is mica, and one of the things that I've done in my career actually quite recently is worked on techniques to measure the aspect ratio of mica particles. In fact, I presented something on it at the recent clay conference in Dublin. Um, and so I like mica because you can get ridiculously high aspect ratios out of it, and as well as working on it, when I go to the beach at Par and I go windsurfing, the sand sparkles with mica. So yeah, it's a very familiar and mineral of mine.
Oh, I'm glad you managed to pin you down to one at least. It's a lovely combination of the professional and the personal. What
Mm.
about yourself, Deeba?
Yeah, well, I would say it's kaolin
Oh, got
because
to be.
yeah, it was the start of my career. So yeah, it was ECC, English China Clays, that I joined in 1988. Um, so helped me throughout my career. It's all around us. I was product manager for kaolin, both in Cornwall and also Brittany. So I had the opportunity to, on a quarterly basis, to travel to Brittany across on the ferry to Plumeur, and again we're still producing clay there. It's been produced in those here for over 175 years. We're always finding new uses for it. It's an amazingly versatile and interesting material, and even though you think those materials, the fact that within the micaceous granites here in Cornwall, where we extract kaolin, we're also now looking to extract lithium. I know, as Imerys British lithium, as a effectively what was once a waste stream is now is potentially a source of lithium for the future for Europe. So yeah, it's always changing, always interesting, but kaolin I think is in my heart and always will be.
Fantastic. Thank you so much to you both for sharing your experiences, insights, etc. It's been fantastic. Deeba, John, thank you.
Thanks a
All
lot.
right. Thank you
Bye.
very much, Alistair.